So today we're working on two-step equations. Now, this is all assuming you've sort of gone through the type of one-step equations. I have a video kind of covering that in quite a bit of detail on my channel that's called Intro to Equations. So the equations we sort of worked on before, and I'll do a little quick summary of that on this side. So these kind of questions we worked on before, they were what we called one-step equations, mainly because the solving them requires one step. So we looked at something like, say, oop, off to a good start here. We have, say, y minus 2 equals to 5. And we established this idea that as we make what we call it in mathematics, making y the subject, so the having y on its own and wanting to figure out what that number is, the kind of operations we took, we noticed that in this example, y, we expect it would be greater than 5 because it's a number that when 2 is subtracted from it, it gives 5. So we'd expect y to be a number that is 2 greater than 5. So we can establish that y is 2 greater than 5, which is 7. And another example, so we have some number x when divided by 3 gives us 6. This is essentially telling us that, okay, 3 goes into x 6 times because x is being divided into 3 separate bits, which our denominator tells us, and the answer we get there is 6. So we can also take 3 lots of 6. So we're doing the opposite sort of operation when we're bringing these numbers on the other end of our equal sign. So here we had a negative 2, and that became a positive 2. Here we have x divided by 3 equals 6. So x would be 3 lots of 6, or 6 times 3, which gives us 18. Now, I'm not going to go too in-depth with it here because I've covered it quite extensively in my Intro to Equations video. Now, we can see here on our examples on the left, we can't solve these sort of just in one step, can we? Because we've got here some number, x, when multiplied by 4, and 3 is added to it, we get 35. Here we just had one step. We just kind of added 2 on the other side of our equals sign here, and that was enough. We, multiplied by 3 here to have the x on its own, and that was enough. But here, we want to solve for x again, obviously, and we need 2 steps here because, well, x is multiplied by 4, that's one operation, and that whole number is added by 3 to give us 35. Now, what can we do here, right? Now, let me just change color here. Our x is first being multiplied by 4. So we can think of this as sort of one kind of entity. And when 3 is added to that, we get 35. Now, we can use these kind of rules and trends that we established in the last video. Could we then, with the same logic, say that, okay, well, if 4 lots of x plus 3 equals 35, could we then say that, well, 35 is 3 more than 4x? So we could then say that, well, 4x then should be equal to 32. Or we've subtracted 3 from each side here. 35 is 3 more than 4x because 4x plus 3 gives 35. So 4x then should be equivalent to 32. And we've chipped away at this extra number here. So we've gotten rid of this 3 on the left-hand side, and we're just left with 4x. That's what we want. We want our x on its own. We want to find a value for x that satisfies this equation. Now, we have here, now this, check it out. We now have a one-step equation left. There's only one step to go. We've done the first, and we only need one more. Hence why it's a two-step equation. So we have 4 lots of some number gives us 32. So we can once again do this opposite operation. Our x now can become 32 divided by 4. Because we're saying, okay, well, our x is telling us how many times 4 goes into 32. That's why we always kind of have this reverse operation. When we have a multiplication and we want x on its own, we're dividing the number multiplying by x on the other side. Our pluses are minuses on the other side of our equal sign, and so on and so forth. You can refer back to the previous video if you need a bit more clarification on that. And here we're left with x equals 8. Now, I've given you this, sure, that's cool. But the kind of beautiful thing about equations is that once we find a solution for x, we can always check it. Because if indeed x equals 8, then our initial equation that we laid out, our 4x plus 3 equals 35, that should still hold. So let's just check that. I'm going to do this in a different color. Do it in blue. So we're going to check this. So if x equals 8, then 4 times that x plus 3 should give us 35. So 4 times 8, what does that give us? That gives us 32. And when we add 3 to that, 32 plus 3 equals 35. Tick. We've found a value for x that satisfies the equation. This x that we found makes our equation true, because we said in the last video that in equations, the value on the left equals the one on the right. The left and right are equivalent statements here. That's the essence of kind of solving these equations. Now, I've got a couple more examples here that we can try together. Now, sorry guys, I'm a bit sick here. We have here that 2x, when 8 is subtracted from that, we're given -4. Now, I'll give you, if you feel confident with the next two, feel free to pause and have a go at them and then check them later once I've finished them. Or you can just work through them with me. Now, this thing on the left here is equivalent to -4. So when 2 is multiplied by x and 8 is subtracted from it, we get -4. So by that same logic, we can say, well, I can then also say that my 2x, we said before, our 2x should be a number greater than -4, because when 8 is subtracted from it, we're left with -4. So our 2x is 8 greater than -4. So it's -4 plus 8, which, because I'm a bit short on space here, -4 plus 8 gives us +4. So I'm left now, once again, with a one-step equation to go. So 2 lots of x equals 4. What does 2 have to multiply by to give us 4? And here you should get that your x equals to 2. Once again, we can, well, actually, I'll leave this for you guys to check. So we have a value for x, and just to save time, have a go at substituting that into your left-hand side, our 2x minus 8. And if that gives you negative 4, which is the number on the right-hand side, our equation has been satisfied. We've solved it correctly. Now, one more example down the bottom here. Now, instead of kind of a multiplication with the x, we've got, well, this is almost a 3-step equation. So I've kind of added this as a little bit of a challenge question, because we're doing an extra step, but everything kind of still remains here. Now, we have a 4x, 4 multiplied by some number. When all of that is divided by 5, and 3 is subtracted from that whole number here, we're given 5. Now, the kind of easiest way we could go about this, well, we can treat this as sort of its own thing. And when 3 is subtracted from that, we're given 5. So this whole number is then 3 more than 5. So this kind of unknown number, we don't know it because we don't know what x is. When divided by 5, it is equal to 8, because this number, when you subtract 3 from it, gives us 5. So it's 3 greater than 5. Okay, now here we've got still 2 more steps. So I kind of lied. I said, we're doing 2-step equations today, but this is just a bit of a challenge one. So we have a number, 4x, which when divided by 5, we get 8. So 5 goes into this top number 8 times. So we can say this number on the top, our kind of numerator here, is 5 lots of 8. See, we're always kind of, sorry, it's a shocking 5. We're always, when we're moving things on different, when we're manipulating these equations and moving these numbers on the opposite side, like here and here, we're always doing the reverse operation. And that you'll see in the next video can be very powerful when solving for multiple kind of pronumerals. What we've established in our first video, in my previous video, Intro to Equations, is that we always observe this trend that on the other end of the equal sign, our sign changes from our intuitive understanding of kind of our mathematical operations, adding, subtracting, multiplying, dividing. Now we're almost there. We're very close here. We have that 4x is 8. Oh, that's not helpful, is it? So 4x is equivalent to 8 lots of 5, which is 40. So we should kind of be used to this by now. 4 multiplied by some number gives us 40. So that some number is how many times 4 goes into 40? Or 40 divided by 4. And that equals to 10. Now, that was a lot of steps, but let's just check this and make sure that we're on the right track. So you can always, whenever you're in doubt, you can always check back. You can go, okay, well, if I found x to be 10, if I found x to be 10, then 4 multiplied by 10 divided by 5, and subtracting 3 from that should give us 5. So 4 times 10 gives us 40. When we divide that by 5, that gives us 8. And when we subtract 3 from that, that gives us 5, which is our right-hand side. We've proven that x is, in fact, the number that satisfies this equation. All right, I've gone a bit over time, but I'll leave that with you, and hopefully that all makes sense. And have a go at playing with these types of numbers in your textbooks, or I can add some more challenging questions at a later time.